July 23, 1942. Hickam Field, Hawaii, 3 a.m. Technical Sergeant Joe Sarnofsky knelt in the belly of a B-17 Flying Fortress with only a flashlight for company and 7 separate Army Air Forces regulations stacked against him. The tanker he was cutting into was due to deploy to the South Pacific in 18 hours. He had no engineering, no maintenance clearance, no authorization of any kind. Discovery meant a court-martial. But a week earlier, he helped bury 2 pilots' good men, who had died because an enemy cannon tore a wing off. But because one Japanese bullet slipped through a fuel tank, one incendiary round, a mist of 100-octane aviation, gasoline, a flash. The fuselage became a furnace. The aircraft remained structurally flyable. The crew had maybe 20 seconds to jump. Only the navigator lived. Sarnofsky had watched a version of that sequence 5 times in 3 months. Different crews, different missions. The same terrible math. 1 round into a fuel tank equals 1 dead bomber. Axis pilots knew the logic too. Tanks were big targets packed with volatile fuel. 1 lucky hit did the work of hundreds. The solution already existed: self-sealing fuel tanks, proven by the British since 1940. American procurement timetables were clear. Testing, contracting, then phased installation. Retrofits would start in September. The war refused to wait. Neither would Joe. In a supply shed, materials sat awaiting authorization. 3 hours earlier, he had liberated them. Vulcanized rubber sheets, treated fabrics, and fuel-resistant adhesives. He'd studied British layouts and understood the principle: layered rubber that swells on contact with gasoline, squeezing bullet pads shut within seconds. This would not be factory. He was lining existing tanks, never meant for retrofits, shaping rubber by hand in a space better suited to a contortionist than a mechanic. By sunrise, 3 tanks in that bomber were fully lined. The aircraft would carry marginally less fuel, but its crew's odds of survival had just transformed. The maintenance officer found out. The paperwork moved faster than any bomber. Unauthorized modification of a military aircraft, misappropriation of government materials, violation of maintenance protocols, hearing date Huli, 28. What happened next? Canceled the proceedings. On July 26, the very bomber Sarnofsky modified returned from a run over Rabaul with 14 bullet strikes in its tanks. The crew watched fuel spray for moments at each impact, then stop as the liner took over. They flew 300 miles home on tanks that would have been a death sentence a week earlier. Charges were dropped. The same officer who filed them recommended a commendation. Within 2 weeks, Hickam Field put Sarnofsky in charge of teams retrofitting every bomber on the base. Within 2 months, his flashlight methods were formalized into official retrofit procedures. Within 6 months, self-sealing tanks became mandatory on American combat aircraft. Survival statistics began telling the story, decisively. Revolutionary. Aviation had known since World War I that fuel systems were flying fuse boxers. The interwar years, obsessed with speed and range, accepted the risk. Tanks were designed to cram maximum fuel into minimum space. The fact that they turned aircraft into bombs with wings was considered an unfortunate but tolerable trade-off. The Spanish Civil War 1936-1939 confirmed the nightmare: incendiary rounds against unprotected tanks ended fights in seconds. Yet most nations deferred hard fixes. Britain, staring down invasion in 1939, didn't blink. The RF adopted the layered rubber concept, much of it rooted in American chemistry of the 1920s. The results were blunt. Aircraft with self-sealing tanks came back. The U.S. took notes and filed them. Testing in 1940, contracts in 1941, installations scheduled in 1942. But schedules do not intercept bullets. Early Pacific data were harsh. Roughly 40% of American aircraft lost in combat were lost to fuel system fires, not structural failure. B-17s could limp on 1 engine, fly with half a wing shredded, and land with tails chewed to lace. 1 unsealed tank puncture ended everything. Fighters were worse. The P-40 Warhawk carried tanks directly behind the pilot. A single hit could turn the cockpit into a crematorium. Pilots flew with a fatalistic mantra. You kept going until something important got hit. Usually the tank, usually fatal. Where protection existed, the difference was visceral. U.S. Navy F-4F Wildcats with sealed tanks took hits, leaked briefly, then kept flying. Pilots returned home with perforated tanks and enough fuel left to land. Sarnowski's unauthorized fix became the catalyst. It proved what memos and lab tests couldn't. Field retrofits are possible, practical, and indispensable. One surviving bomber forced the bureaucracy to acknowledge urgency. Self-sealing systems were a chemistry tightrope. Layers, outer aluminum for structure, untreated rubber for flex, a vulcanized fuel-reactive layer that swelled 5 to 10 seconds after contact with gasoline. Choking holes shut, an inner fuel-resistant fabric to prevent long-term degradation. Weight mattered. About 8 pounds per 10 gallons protected. On a B-17s, approximately 2,700 gallons. Protection added approximately 2,160 pounds. That meant a modest hit to range or bomb load in exchange for a massive boost to survivability, a trade any crew would make. The real hurdle wasn't science, it was installation. Factory fit during production was straightforward. Field retrofits was surgery in a parking lot messy. Cramped, crucial. Sarnowski's proof knocked over the first domino. Material command engineers arrived, documented his process, refined it, and standardized the field timeline. 48 to 72 hours per aircraft. In 3 weeks, the experiment became policy. By September 1942, retrofit lines ran around the clock in both the Pacific and Europe. Supply chains strained to deliver rubber liners, adhesives, and tools to every airbase. The scale was enormous. The results were immediate. By December 1942, roughly 60% of U.S. combat aircraft had self-sealing tanks. By June 1943, over 90%. The statistical shift was dramatic. Fuel fires fell from approximately 40% of combat losses in early 42 to 8%. In early 43, thousands of lives, thousands of airframes. Production surged to meet it. By mid-1943, U.S. Rubber and Goodyear could equip 2,000 aircraft per month. By mid-1944, 5,000 per month. Total wartime output topped 150,000 complete systems. Cost, about $800 per B-17 set. 1% of the bomber's price. $300, $400 for fighters. A bargain when one saved aircraft might be $80,000 of metal and millions in training, experience, and ordnance, never mind human lives. Luftwaffe pilots complained in late 1942 debriefs. Bombers hid in the tanks no longer burned. Japanese fighter leaders observed that P-38s and later U.S. types shrugged off what used to be killing passes. Axis tactics shifted toward cockpits and engines harder. Smaller targets demanding more precision. Incendiary machine gun rounds gave way to explosive cannon shells. These tore metal, but ignited fewer catastrophic fires. More U.S. aircraft came home. Fewer died in flames. Confidence is a weapon. Knowing a hit didn't automatically mean cremation changed the way Americans flew. Pilots pressed attacks they might once have aborted. A P-38 pilot over Rabaul in November 1942 logged 7 hits, 4 through tanks. He watched, spray for a breathless second, then silence. He flew 240 miles home. Self-sealing tanks saved my life. I should be dead, his report read. In March 1943, a B-2 limped back from Germany with 23 holes, 6 in tanks, every one sealed within seconds. The crew chief pointed at stained but dry patches and told the pilot flatly. Before this, he'd have exploded over Germany. Now you landed. The Pacific punished rubber. Heat and humidity accelerated degradation. Tropical fuel contamination could slow the swelling reaction. Engineers formulated tropical-rated compounds that held up in steam bath conditions. Maintenance doctrine matured. Self-sealing liners had finite life. Inspections every 100 flight hours. Relining if swelling performance declined. Training exploded. By 1944, every major airbase had specialists in fuel system protection, many taught by men who learned the hard way, including Sir. The greatest benefit extendeth past single sorties. Crews who lived through their first missions became veterans veterans survived and killed at far higher rates. Every saved crew trained replacements, multiplying effectiveness. Enemy accounts acknowledged the gap. Captured Luftwaffe pilots admitted, "We hit the tanks. They do not burn." Japanese ace Saburo Sakai later wrote of the sudden American resilience spray visible. Fire absent, kills denied. The contrast was brutal. German designs seldom carried self-sealing protection. Japanese fighters prioritized range and agility, often flying without armor or sealing. The Flying Lighters nickname was earned. As American aircraft hardened and American pilots survived long enough to learn, attrition hollowed Axis experience. The story of the Hickam mechanic who gambled his career to save strangers spread through maintenance tents like scripture. Sarnowski himself shrugged off myth. He had simply installed British technology that should already have been there. But the Air Forces took note. In February 1943, he received the Legion of Merit for initiative that began unauthorized and ended as standard operating procedure. 3 crews, whose aircraft he demodified, stood behind him on the parade ground. All 3 had taken fuel tank hits and flown home. Post-war analyses ranked self-sealing tanks among the most consequential life-saving technologies of the conflict, cutting overall combat losses by roughly 20 to 25% and saving thousands of aircraft and tens of thousands of aircraft. The wartime investment, about $200 million, returned hundreds of times its value and saved machines, missions, and men. The legacy outlived the war. Korea, Vietnam, and modern air forces treat fuel system protection as fundamental, not optional. Civil aviation borrowed sealing know-how for leak prevention and safety. Industrial pipelines adopted swelling compounds born in hangars. In museums today, you can find a cross-section from a B-17 tank, pepper, with sealed holes each. A frozen moment when chemistry beat fire. And it all returns to a midnight decision beneath the ribs of a bomber. 1 sergeant, 1 flashlight, 1 violation of the book in service of the men inside the book's margins. Rules exist to protect people. When the rules start killing them, the brave don't wait for a meeting. They fix the tank. If stories like this move youth, the quiet decisions that save thousands stick around. We tell the untold wartime innovations that turn statistics into survival.